turn on? Okay. Where is Tassin?
Let me text him right now.
Okay, so bottom line, why are we having this session is virtualization is a very important piece of our sales strategy. The better understanding of virtualization you have and how it integrates into the entire IT infrastructure landscape, the better you are going to be at selling IT infrastructure. You may not be able to grasp everything, but if you don't make an effort to learn it as a process, you are not going to be a good salesman at any point, and specifically from an IT infrastructure standpoint. Okay, and the way I present it, you will start appreciating how the pieces fit together. Okay, and that's why I have used it as a cornerstone of my sales strategy. Okay, now we are talking about virtualization, and virtualization is, as you can see, and during my process of teaching, I would like you to focus on the terminology as it relates to pure English without associating any strong technical aspects to it. Then understanding the technology becomes easier for you. Okay, so virtualization. What is virtualization? It's just about being virtual rather than physical or real, right? So in this particular aspect, the term virtualization that we are talking about starts and refers to server virtualization. What does it refer to? Server virtualization of servers. Now, taking that concept, lots of other things have been virtualized. Security has been virtualized, network has been virtualized, storage has been virtualized. Almost everything there's a possibility of virtualization has been virtualized. But our focus, or how we are going to learn about virtualization, is through the process of server virtualization, which is easier to understand, easier to digest, and by far provided in the IT industry, provided the best value for money, best ROI. Sometimes in as less than 3 months, 4 months basically, the investments that you made, you actually got return on investments. But in order for you to understand server virtualization, it is important for you to understand what does non-virtualized environment look like. What does it entail? What does the physical environment look like? If you can't understand a physical server and its concept, and I have repeated multiple times, but I haven't seen people take action on it. If you don't know what a physical server looks like by touch and feel, and what an operating system install on that looks like, and how you actually work with a server, you will never be able to appreciate server virtualization. You will never be able to talk about it with confidence to any customer that you ever are going to interact with. Whatever you are going to be talking is from non-experience, is going to be hooks. So I don't want to have processes defined for everything, but if people don't take the initiative to kind of set up a time in the lab and to do two simple things that can be done in 15 to 20 minutes or half an hour at the max, I will consider it as non-initiative. Basically, I will consider that people are not interested in learning about that. Okay, I really want change in the direction, basically, where as I'm changing my direction and basically going down to having a very professional approach to sales training over here. Okay, so let's begin with what a physical server is. I have taken some of you to the lab and shown you a physical server, but physical server is nothing more than any computer that you have ever used in your life. Okay, what does a computer consist of? What does a computer consist of? Okay.
Memory.
CPU. Memory.
RAM.
Yeah. What is this?
I'm sorry.
This is, what is this called?
RAM.
RAM. Okay. Then what?
Hard drive,
Okay.
storage.
So this is basically compute, right? And this is basically again falls under the realm of compute, you can say. Then storage is physical storage. And then what do you have?
Operating system.
It comes later.
Motherboard.
Computer physically.
Motherboard.
No. We basically talk about network.
Network interfaces.
Network.
Okay, network and other types of interfaces. This defines a laptop, this defines a workstation. If you don't understand any of these terminologies, please raise your hand. You understand what a laptop is, correct?
Yeah.
Desktop. Do you understand desktops? Okay, what's the difference between a laptop and a desktop?
Desktop will be like something like this, what has a tower and
Good job.
something you can't use mobile.
Okay. You can't define a laptop or a desktop without this. Okay? If you have to define a laptop in terms of the compute capacity it has, and the compute capacity is defined by the CPU. What is the CPU? Central Processing Unit. Okay? It is defined primarily by there are 2 or 3 companies that sell, and you basically have to choose one of those. What are the 2 or 3 top companies that sell CPUs? Intel,
AMD.
Intel, AMD. Okay?
NVIDIA.
Huh?
Those are graphic cards.
GPU, but yeah, you're right.
Yeah, and NVIDIA is correct, but there is a specific market for this. Okay, and then right now, Broadcom basically is coming, right? And then there is another one small market for Cavium network. Okay, this is our customer. So, but if you know at least this much, you are good. How is the CPU selected? How do you define CPU? What type of CPU you want?
People typically want speed.
People
They don't
define
performance.
the CPU by
Gigahertz.
No cores.
Gigahertz, right? So that's speed.
yeah, speed, basically speed. And I think more important than that is the version of the CPU sometimes. Okay? Each company basically puts its version out, and version has specific capabilities associated with that. Right? They usually have a name associated with that, and then they basically associate a name, right, with the CPU version. Okay? And then you have the speed, which is usually defined in gigahertz, right? Then what do you have? These are all things, if you don't know this, you'll not be able to read and help us basically. You'll not be able to understand any word that the customer specifies for you, right? They specify the specs, they will be throwing these terms out at you, and you'll be staring at them basically without making, without giving them an impression that you understand what their requirements are. Okay? And the most important thing is cores. Okay? The CPU is defined by the number of cores. The higher the number of cores, the higher the cost for the CPU is going to be. Okay? The higher the number of cores, the higher the cost of the CPU. Okay? And then what else?
Cache.
There is a cache on the server itself, on the processor itself. Okay? That defines the capacity of basically the quality of the CPU as well as the processing capability of the server. If you don't understand the terms cache and how it in fact affects the performance, we can have a separate discussion about that, because I'm not talking today about that, but that would be going down much granular. Okay? Now in terms of RAM, okay, what are the things that are associated with RAM?
Capacity.
Capacity, how much capacity are we generally talking about for laptops?
Gigabytes.
How many
Yeah,
gigabytes?
terabytes.
How many gigabytes do your laptops usually have?
16.
From
4, 8, 16, right? 4, 8, 16. How much capacity do the servers usually have? Basically right now the ones that you're ordering.
Terabytes.
Most of them are still in gigabytes, okay, but they are going towards the terabytes. Most of the servers that we order are minimum right now 16. There's nothing that goes below 16. 32, 64 is basically becoming very common right now. Okay, so if you should basically try to gauge the size of the the deal, and the server cost is directly proportional to the RAM basically. Okay, there are a couple of things we will talk about that are specific to how the RAM sizing and the module size plays into the cost. Okay, so in a server right now there are a specific number of slots that you can populate. Each server has a limit that it can start with. Paying attention to me, each server starts with a minimum of, let's say, 4 to 8 gigs, but then it can scale up to 256 gigs by putting in 16 slots of 16 gigabytes each, right? So these are things that you need to know as to how the memory expansion happens in each of your computers. Okay, workstations, you may call it whatever it is, right? Now after that you specify. Now there are specific things associated with RAM. We will discuss about them later. There are specific types of DR. There is DDR, there is LDDR, there is MDDRs, right? So you have to ultimately get to the level where you are able to distinguish between what the cost of each of them is going to be and why, right? We'll not touch on that later because today is a very, very basic class. And how about the physical storage? What kind of drives do you have?
SSD.
Okay.
SSD,
Solid
SD, HDD, SSD.
Okay, what is HDD?
spinning disk.
That's spinning disks. Okay, what are the speeds they come in?
72 RPM, 7200 RPM,
Okay.
56.
7.2k RPM, then
10K
10.
and 15.
and then 15k. These are things that, and what are the two flavors they come in? One of them is obsolete right now. What are the two?
Spinning disk
Bus
and
time.
flash.
No, that's basically the SSD is
I'm
old.
sorry. Okay.
Okay, what are the two types of HDDs that you used to have on your computers?
ID.
SAS, okay.
and
One used to be IDE.
IDE.
Okay. They are gone right now, right? Right now all of them are SATA, SATA, right?
Set of state drives, basically.
SATA, they are called SATA, right? So this one is obsolete right now, right? SATA, SCSI basically is. So this is, iSCSI was the protocol, and right now you basically have iSCSI is also getting obsolete. Basically SATA is what you get right now.
SATA
Okay.
is derives from HDD.
HDD, so SATA, basically when you take a look at these computers there, they have specific cables that connect the computer board to the hard drives, and those are SATA cables, and they are basically specific connector types, and the protocol, basically the data is transferred through what is referred to as a bus, and the bus that is going to be used is basically SATA. Okay. The reason why you need to know is customers are going to specify that to you, that they don't want iSCSI, they want SATA drives. Okay, so if you don't know what SATA is, you are going to be confused. Okay, now these things, they derive their performance, or basically the bottleneck for them is the speed of the disk. Okay, if you take this versus this versus this is going to be very slow to access, and your experience, if you are running a movie, you may have a challenge over here. Okay, versus these are going to be slightly better if you are running a movie, but if you really want significantly high performance in terms of getting your data into RAM, right, SSDs are going to be what is referred to as flash memory. Okay, the only thing you need to know about this is the data is stored there, and there are only so many number of reads and writes you can do on a flash. After that, the age of the flash is gone. Okay, but they design it in such a way that your computer's life is going to end first before the SSD's life expires. But they have 10,000, 20,000 writes on each cell. After that, this basically becomes useless. Okay? If you write to that, 1,000, 10,000 times, there are basically specific cells that you can write to only so many times. After that, it loses its capacity to store. Okay. Now, in terms of the network, what is network? What is network? Anybody outside of Gajendra and
Your Ethernet, your Wi-Fi, basically.
Your Wi-Fi is your Ethernet, and then
Right. What is it called? It's like your network card, basically.
your network
right?
cards, network interface cards.
Right.
Right. So on your laptops, how many network interface cards do you usually have?
Just two, right?
There is one wireless.
Right.
And there
one
is
for the
one
physical,
wire.
one physical.
Right. What if you wanted to connect to multiple places? What do?
You add more network cards.
Add more network cards. So you can actually connect it via USB as well. Or if there is a small slot in there, you have to buy something and then insert it. Right?
They used to have those, like the network cards that you actually have to plug into the laptop, right?
Plug into the laptop. They used to have that basically. Okay. Now this is the basic structure of any computer in the world. You take any computer in the world, you can call it a server or a laptop or a workstation or anything you want. You put it in different chassis, the function is the same. Okay? When the computers are designed by their manufacturers, the only thing that is visible to an engineer, the casing is immaterial to the designer. What they are going to be telling is how much memory should this box be able to supply from zero, or basically from the minimum to the maximum. How many networks or USB ports should this particular hardware design be able to support? Is everybody able to relate to this? So what I'm saying, please ask. Okay, please ask. If you're not able to understand, don't give me those blind. You stare at me blind.
What are
blank
reads and
stares.
writes? Is that IOPS or is
Reads
that
and
something-
writes basically for SSDs is writing to it is basically done by input output instructions.
So that's exact. Okay, so it's input and output.
Input output.
Okay.
But I'm talking about right now. I'm talking about the concept of hardware, right? If I am asked as a manufacturer to design a laptop or a server, I'm going to say the minimum this is going to handle is 4 gigs, the maximum it can handle is 256 gigs. The minimum it's going to handle is 8 gigs, the maximum it can handle is 512. Okay? If I am told that I need a server that can handle 16 NIC cards, okay? I need to be able to kind of design that 16 NIC cards because that can be a requirement. If I am told that I need to have support for 4 NIC cards that are 1 gig and then 2 NIC cards that are 10 gig each, I should be able to provide that. Right? These are the things that customers are going to be requesting from you. Did I make myself clear?
I don't know what a NIC card is.
Network interface card, basically. Network interface cards. So if you buy a server, if you buy a computer right now, your computer, and then you have a need to connect one of your Ethernet ports into 1 gig network, and then you have to make sure that this laptop somehow connects to a 10 gig network. So you can go and remove your hard drive, buy a 10 gig network card, and put it in the place of your hard drive, and it will provide you connectivity to the 10 gig network. Okay? That capability and flexibility is there to a very high degree in servers.
So what happens to your storage if you take your hard drive out? अब hard drive निकाले तो storage को क्या होगा?
I'm talking about
The network card.
DVD drive.
Oh,
DVD drive.
Oh, okay.
Right? If you take your hard drive out, you can actually boot from the network card as well. But basically in servers, what they do is they give you that kind of flexibility. You basically can say, if you take this motherboard, you can start your RAM and work from 16 gig to 512 gig of RAM. That's the flexibility. Then if you want NIC cards, I can provide you 16 1 gig NIC cards. Or I can provide you 4 1 gig NIC cards and 4 10 gig NIC cards. These are the things that servers will ask you for. Okay, instead of the storage, you will basically go and take a look at the server. In your laptop, you will be able to provide how many hard drives? Probably one, maximum two, right? There they will give you option for 16 drives. Okay, and you can choose what type of drives you want. You can choose, 4 terabyte drives for SATA right now. You can choose 500 GB drives for SATA, right? You have lots of variations in speed. So the more flexibility is available on the computer motherboard, that option basically is referred to as a server for all practical purposes. Okay, that is not the functional definition of a server though. Any computer from a hardware perspective that gives you more flexibility to use it in many different ways, that piece of hardware, that computer is called a server from a hardware standpoint. Okay, so the difference between your laptop, can your laptop, now with that question, can your laptop be converted into a server?
Yes.
Yes. How? Instead of your laptop Windows client operating system, right? If you install a Windows server, it will become a Windows server. All the same hardware, right? So there is no difference on the hardware. The server hardware that is designated as server hardware just gives you more flexible options in terms of defining what your hardware should look like. That is the physical definition of a server. So from a sales standpoint, our internal discussion should be, or our internal validation should be, if I ask you questions on any of these things, and we'll try to create a list of questions, you should be able to comfortably answer those without, having without giving a blank look. You should be able to kind of relate to these terms and be able to kind of say with accuracy and confidence that this is what it refers to, and this is how it's going to be configured, or this is what the customers are going to ask me, right? For how much RAM, how much cores, right? What does the cores relate to in terms of performance? These are things that everybody who is basically doing sales in virtualization environment should be familiar and comfortable with. Okay, so that defines our physical server. Any questions on the physical server's core components? Okay, now if you have understood the physical server, right, let's move on to what makes the hardware now a real server. I briefly gave you an example, and this concept should be very, very clear in your minds as well. I can take the biggest server possible and put my operating system, my 2000 Windows, whatever we are using, Windows 10, and I can use it as a personal desktop, right? I can install it I can install my Windows 10 operating system on a server, and it will work like my personal desktop. I can run Outlook on it. I can run my gigantic applications for desktop. I can run my NVIDIA graphics cards on it to give me the best possible experience of my video games, right? That will be the use. But what I have done, I have taken a piece of hardware that's called a computer, and even though it had extraordinary amount of capabilities, it was designed as a server. I'm using it as a workstation. I'm using it as a desktop. I'm using it as a laptop, right? But if I take the same piece of hardware or lower quality hardware and I install a server operating system on it, it makes it a server. Is everybody clear about that? Should I repeat it?
So the hardware is the capability, and the software that you install on it would be the function of that.
Will make it a server or not, or a workstation.
Okay.
The operating system is going to make that piece of hardware a server or a workstation. Okay? Now, fundamentally you have to understand one concept about the client and server, or what does server actually mean, right? There is an entire concept. If you go and take computer networking classes, there is a thing called client server. The basic fundamental concept of a client and server environment is a lot of clients are accessing one server where there is information of interest. For example, we have files that all of us have to share. We are putting it on Google. Google is giving us that experience of all of us being able to access that information and look at it at the same time. We are logging in from our operating systems and browsers. Chrome browser is the client, and Google Docs is the server. We can create the same environment in Microsoft. We can put all our documents on a shared server, and we can use our desktops to basically access those documents, and then again it's going to be a client server environment. Clients usually do not give you the capability of sharing with multiple clients. Servers are designed to kind of give you that information. Another good example could be your banking transactions that you do. You're logging into your bank's server, and the bank is giving the information that you have authorization to. Okay? So understanding of the client server environments has become easier right now. So if you install a Windows 2003 server, you will get many more services from that server operating system than you would get from your Windows 10 client, right? And we are not talking about the server, the operating system architecture, so we'll not go over that, but I'm just talking to you from a experience standpoint that if you don't understand the difference between a server and a workstation and a server software and its application and use, you will have a difficult time understanding the customer's requirements. Okay, so it's very important that you understand and have very clear distinction between a server. And the best way to do that is go ahead and look at one of our servers, how it looks, what are the features it provides, at least be familiar with one or two features. Okay, so I have made two things very, very clear, and that is basically the physical hardware does not make the hardware a server. It is the operating system that is installed on the hardware that will make it a client or a server. This is the most important takeaway I want everybody to have. Okay, now let's talk about the case for virtualization. Okay, since we know what a server is, we will try to make a case for virtualization and why virtualization came into existence. Okay, so I'll give you some specific examples about our company and companies in general. You may not know, but let's try to list the servers that we have in our company, right? What are the services that we are using collectively in our company right now? Anybody wants to take it? What is our service? Huh?
QuickBooks.
Good job, very good job. So we have QuickBooks. How many people are accessing it?
5.
Approximately 5.
5 licenses.
Right? 5 licenses.
Salesforce.
Yes. So QuickBooks Salesforce is not on our.
Oh, I see on this.
Is not on our prem. Okay. Salesforce is not on our prem.
I see.
So let's say QuickBooks server, right? If you look at it, we have that server that is, I believe it is, some sort of, I think it's a, let's say it's a CPU with about at least 4 to 8 cores. Okay, and I believe it has 32 GB RAM. Okay, and at least I think 2 1 TB hard drives and redundant. Okay, 2 times that are redundant. Do you understand what redundancy is?
You typically have two of the same thing, just to make sure if one goes down, the other one's still
So
active.
they are
Sure.
mirrored. They are mirrored. So
I've
the
mirrored
data
them.
is basically returned to both of them, just in case one goes out. Basically,
Then your whole thing doesn't collapse,
The whole
right?
thing doesn't collapse. So this server is there. What is so basically? Let's say we spend about $2,000 on this, right? It's not that big of a cost, but it's. Kumar, you can sit here if you
I'm gonna.
So we spent $2,000 on this and got this server box, right? Now, what are the other resources the server is consuming? What does the server need to be, to do its job?
CPU.
Oh, it's already there, right? It's basically consuming power, correct?
Mhm.
Yes.
And if we had lots of them, then we basically also would be expecting to stay in a cool environment. Okay? Now let's imagine this, correct? This is a server, CPU, this is running 24/7. Can we turn it down?
No.
You cannot, correct? How many people are accessing it?
Five.
5. How much time during the day?
4 or 5 hours? I mean, total?
Yeah, 8.
8 hours.
8 hours average.
Right.
8 hours.
So even when you are interacting with it, here's basically what I want you to understand the difference. 4 to 5 hours, 5 people are accessing, let's say, they are utilizing it all the time. But how much of a load is that putting on the server?
I guess it's not a significant load because it's not being accessed like all day long by multiple, like by 40 or 50 users, right?
Even if it's 40 and 50, how much does the server have to respond? You do one interaction, you create one invoice.
Just 10%.
Compared to the capability of the server, right? Even for example, this server, just to kind of let you know, even if you load 1,000 people on this server, the server will not have a problem.
Mm.
Even if you load 5,000 people on this server, believe it or not, the server will not run out of CPU power. That's how much power it has.
Is that because of the cores that it has?
It is basically the human interaction that we have. So for example, if this server were streaming data to you back to you,
Right.
right? It has huge amount of data that it needs to support. Correct? If it's processing the data, like if video processing is happening on that one, yes. If you are sending it an image and it's doing a search algorithm and basically sending it back to you, yes, 10 people can choke that machine. But QuickBooks transaction is like probably 5 to 10 key interactions that are exchanged there.
Right.
Whatever you enter in there is basically some text. That text is basically being sent over there, it's being logged into the database, right? So the utilization of this, if you go and actually do the metrics on this, is less than 1%. Is less than 1%.